Hi guys, today we want to talk about enzyme kinetics derivation. And today specifically we want to talk about the non-initial rate version of the enzyme reaction. So what we have here is an enzyme and a substrate undergoing a reversible reaction to form an enzyme substrate complex ES, and then another reversible reaction to form E plus P. Now in the initial rate version, the backward reaction from E plus P to ES is pretty much negligible, and thus that helps us to simplify the derivation of such a kinetics. But now that we're not just concerning the initial rate, we're going to consider the reaction rate at all stages of the reaction. So what's it going to be like? First, we have our usual equations. The rate of formation of P with respect to time, we just call that V, is equals to K2 into ES, which is the forward reaction, minus the K minus 2 E times P, the concentration of free enzyme, times the concentration of product. So that's K2 forward, K minus 2 backward. Now that's our first equation. And now what's next? We look at the balance of ES, because usually this we don't know. We have to put this in terms of other forms of other items. And so dES dt equals K1 into E times S minus K1 ES. So that's K1 into E times S. So this is the forward reaction here. This is the backward reaction here. And this is the backward reaction from here to here. So the backward reaction E plus P to ES. And then the consumption rate, of course, this is the forward reaction, ES into E plus P. So in summary, for the ES balance with respect to time, the rate of accumulation of ES equals the inputs, which is E plus S into K1 and E plus P into K minus 2. Then subtract the output, which is ES into K minus 1 and ES into K2. So this is what this equation is talking about. And what's next? Well, since we don't know our ES and E so well, we want to do a simple enzyme balance, which is just this. E naught equals to E plus ES. And these are the so-called equations that we want to start with. And to simplify it further, we will assume that this equilibrium here is rate controlling. So K1, K minus 1, rate controlling. Therefore, in that case, rapid equilibrium is not reached. So no rapid equilibrium. And then we can assume pseudo or quasi-steady state. So that's what we will be going with in this case. So in the quasi-steady state assumption, we will want to cancel this out, and that is 0. That's the steady state assumption. So let's just rewrite equation 2 at the bottom. So K minus 1 plus K2 into ES. So I'm shifting this to the left hand side. And K1 plus K minus 2. Okay. And you bracket the E out, because you can factorize it out. And of course, here you will have K1 into S, K2, K minus 2 into P. Okay, so let's write that properly. K minus 1 plus K2 into ES equals to K1 S plus K minus 2 P. And that goes into E. Okay, so that's equation 2 rewritten under quasi-steady state assumption. Okay, so now what do we do next? Well, we want either E or ES in the form of E naught times something, right? So because we want to eliminate this and this from the equation, we want this only in the subject. I mean, not in the subject. We want this in we want ES or E to be in the form of this, so that when we substitute things back into this equation, it will be a lot easier. So firstly, we want this in terms of E naught per se. So let's have ES as a function of E naught. And then S, E naught is the initial enzyme concentration, or also known as the total enzyme concentration. So we want it in this form because all this can be measured and this cannot. So let's just do that. Okay? So I have this here. I'll just put the first piece of paper aside. Yeah. Anyway, so that is, so we want ES as a function of E naught, concentration of S, concentration of P, and hopefully we will have this EP as also a similar concentration, a similar function, because this is a very good way of expressing. It simplifies a lot of things. So how do we do it? Well, first thing first, we have to eliminate E. Okay, so let's write equation 2 again, just for the clarity. Into E. Okay, now what must we do? Now, this is E, not E naught. This is just E, yeah? And this is equation 2 under quasi-steady state conditions. And we'll need this enzyme balance, E plus ES, to help us. So we want to eliminate this E. So what do? We make E the subject so that we can substitute it later on. Okay, and this will be substituted into equation 2. So now the equation will look something like this. So this is E naught minus ES. Now close the bracket here. So this is going to stay on the right hand side. I'm going to port everything here over to the left. Or even better still, I want to divide everything by this factor here, and I'm going to port this to the left. Okay, so let's do just that. K minus 1 plus K2 over K1 into S plus K minus 2 into P. And I have this ES here. Okay, and you'll get E naught minus ES. And that's quite close to what we want. And then let's just put all the ES on the left hand side. So let's divide the entire equation by this. So K1S, K2 into P over K minus 1 plus K2. That will give the E naught minus ES. And now I bring this over. So ES will be multiplied by 1 plus all this thing here, K1 into S plus K minus 2 into P over K minus 1 plus K2. That will give you, again, this expression into S plus K minus 2 into P over K minus 1 plus K2 into E naught. And so if I just divide everything by that, so I'm going to bring this and I'm going to divide the whole equation by this. So on the next page, ES equals K1 into S plus K minus 2 into P over K minus 1 plus K2, 1 plus K1 into S plus K minus 2 into P over K minus 1 plus K2. So this is the thing. Okay, and that will be your expression. Now of course we want to simplify the thing. So I'm going to do this. I'm going to add a 1 on top to let it match the bottom, and I'm going to subtract 1. Okay, so that gives us the final expression of ES. So 1 minus 1 over 1 plus K1 into S, K2 into P over K minus 1 plus K2. Okay, so that's like, part 1 of it. So we have something quite nice for our substitution back into the first equation. We have something here. Now we just want to tidy that up a little bit more, and then I think we'll be quite okay. Okay. And so that will be, part 1 of the derivation. Stay tuned for part 2. I'll end it now. If not, the video will get really long. So see you in the next video. Bye.